Looks like we're live. Hello everyone and welcome to yet another recreational programming session. So, let's make a little bit of an announcement and officially start the stream. So, I'm gonna pull up my Discord server and take a look at the announcements. Red circle, live on Twitch. Right, and what are we doing today? Today we are doing OpenGL and C. That's right, so I'm taking a break from development port. Right, development port is actually kind of fun. But from time to time I just want to take a break and work on something else. So, and I haven't done any OpenGL programming in a while. And I really quite enjoy it. I really quite enjoy OpenGL programming, so I kind of miss it. So twitch.tv/todding, and I'm gonna ping everyone who's interested in being pinged. There we go. So the stream has officially started. Hello everyone, welcome. So today we're gonna be looking at my OpenGL template that I developed for myself, but I also uploaded it to GitHub so anyone can use it. It's literally called OpenGL Template. So essentially, as you probably know, OpenGL was not designed to be understood, it was designed to be copy-pasted, right? And if you worked with OpenGL long enough, you probably have a similar project where you just like have a template ready to be copy-pasted when you quickly need to start working on OpenGL, right? So it's one of these things that I also have. You can check it out in here. So for people who's watching live, I'm gonna copy-paste it in the chat. And for people who's watching on YouTube, I'm gonna put that in the description. So let me take a look at this kind of stuff. All right. So I'm not logged in, surprisingly. I think GitHub like just logged me out because I didn't use GitHub long enough. So yeah. Let's take a look at this entire thing. I want to clean everything up, and I'm going to fetch the latest stuff. Okay, and of course I'm going to merge origin master. So there's some conflicts, I suppose. I think I'm gonna just reset hard. I don't think there's anything of the use in there. Mentech44, thank you so much for 2 months of Twitch Prime subscription. Thank you, and welcome to our epic OpenGL club. How about that? Thank you. All right, so, and now I'm gonna try to rebuild the entire thing, and if I try to run this template, right, this is basically the example that you will see in here. So one of the things you can do in here is live edit the shaders, right? So let's actually go in here. So it's an OpenGL template. So there's two shaders right now, the fragment and vertex shader, and the main stuff is right now done in a fragment shader, right? So what we can do in here, we can probably maybe update some things, or maybe we can say don't generate this gradient and just like fill everything with a red color, right? Something like this. So it's gonna be out color. And let's say it's going to be vector 4, 1, 0, 0, 1. And then by pressing F5, you can reload the entire thing. Right, and then you can go back. So this is essentially what you can do with this template. It's kind of a shader toy, but local one. And on top of that, you can at any moment pause the entire thing, right? So I can just press space and then step back and forth essentially. So that's the thing I have, and every time I need to work with OpenGL, I just grab this template and copy paste it and adapt it to my case, and yeah. But here's the thing: this template lacks a very important feature for me, and that is basically Vertex Buffers, right? So interestingly enough, like this kind of example is super easy to implement. You just generate like a quad, right? And you use a fragment shader to put a texture on that quad, and that is it. Interestingly enough, we do not use any vertex buffers to generate that quad. Essentially what we do, we render 4 points, right? I basically have a single GL draw call, draw array instance, but I mean that's besides the point. So, and I draw like four 4 points in there, 4 vertices. And in the vertex shader, I'm just using the GL vertex ID to generate the quad. I don't send any information to the GPU, right, about the quad. I just generate the quad on the GPU directly, which is fine if you want to do only like fragment shader stuff, right, like shader toy. But sometimes, like when I copy paste this OpenGL template, I want to have an ability to have some vertex buffers, right? I want to be able to send some vertices with different attributes to the GPU and just like process them on the vertex shader. And this template just doesn't have that, right? It just like has this stub for vertices, and you can only work with the fragment shaders, which is particularly not convenient. And that's basically what I wanted to extend today, right? Essentially, I wanted to add the ability to work with Vertex Buffer for this particular template. Does it make any sense? Okay, we got some subs. Thank you so much, Lucas EG11 for Twitch Prime subs for 3 months. Thank you. Lucas Sig11. I don't know how to pronounce your nickname, but thank you so much. The Sigolo, thank you so much for Twitch Prime, your first subscription, by the way. And JJ55QS, thank you for tier 1 sub. Really appreciate all of the subs. Alrighty. So essentially, my goal is going to be the following. So we have only one quad in here, but by the end of the stream, I want to have like basically a lot of copies of this entire quad, maybe moving around on the screen, right? So this is essentially what I want to be able to achieve. And the template is rather simple, right? It doesn't even abstract too much. So, and it even stores its entire state in some sort of like global variables. Let me actually find its state. Can't find it. Yeah, that's probably why you shouldn't use global variables, am I right? Oh yeah, here they are. So here's the entire state of the program. Fragile people with CS degree look away. Yeah, exactly. And I think at some point I'm going to actually factor it out to some sort of a structure that I'm going to pass around, and that structure is going to be called something like a renderer. But I'm not going to do it like right away, right? First I want to add the, you know, the vertex buffers and stuff, and then we can try to factor it out. So let's actually go ahead and open something like docs.gl, which I really recommend when you work with OpenGL. It's a pretty handy website. Okay, so this is a docs.gl. I'm gonna put it in here. Okay, let me... Did I already close everything? I actually opened 2 Emacs, which is not ideal. Which is definitely not ideal. There we go. So the first thing we want to do, we probably want to create a Vertex Array object. Though I think without Vertex Array object, it's simply not going to work in the current version of OpenGL. And I don't create one, probably because I use like a legacy OpenGL thingy. So I probably need to set up OpenGL to 3.3 or something like that. I remember even having like a to-do to do that. Well, yeah, it's all, yeah. God damn, I need to actually switch to the core profile. So the first thing we're gonna do right now, we're gonna switch to the core profile of OpenGL, because this template is rather old and I didn't know about core profiles at the time of writing all of that. So yeah, let's actually work on that. So let me find glfw. So maybe I can actually just use the headers that I have for glfw in here. So luckily, by the way, the cool thing about the glfw is that like it's a single header, right? And I can just open it up and just like search for things that I'm interested in. For instance, something about, yeah, gl get version string. And what does it do? Return string describing the compile time configuration, but not really. I want to be able to see the OpenGL version, so let's actually keep searching. So get version, get GL version, so there's this thing. GL get window param. Okay, so there was glfw get a GL version, but then it got replaced by GL get window param. Let's take a look. Oh wait, a trib. Okay, so I see. I don't know how to read. And if we take a look, what kind of attributes we can have in there. So This function returns a value, attribute specified window attribute, whose value... Okay, so it refers to something called window attribute, and I wonder if I can find this thing in there. So yeah, it would be kind of cool if the header like contained the whole documentation, so I didn't have to consult the GLFW website, but looks like I have to. So this is something that we'll probably have to use in here, right, to get the OpenGL version. So here we created the window, and after that I just want to like check the window attribute. I'm pretty sure it's going to be something like GLFW OpenGL version like minor and then version major and stuff like that. GLFW window attributes. So let's take a look at that. Let's take a look at that. Attributes. So what kind of attributes? A number of attributes. Okay. GLFW. GLFW context. Yeah, there we go. GLFW context version major and context version minor. So that's basically what we want in here. Right. So, and this is the minor. Right. And it just like returns that. GL version minor. GL version minor. And this one is essentially GL version major. I don't really know why I picked such a long name, right? And also confused everything in here. Then we can do something like printf open GL d and GL version major, GL version minor. I just want to log that to see how it looks like. What's the current version essentially in here? And let's go ahead and do that, and might as well run it right away. So, and the OpenGL version 3.0. So as far as I know, I can have like 3.3, and it doesn't even say like core or anything like that. So this is something that we'll have to set up. Okay. I'm a robot subscribed with 27 months of a tier 1 subscription. Thank you, and welcome back to our epic OpenGL club. Learned a lot from you, and I like your humor. Thank you. Thank you for watching me. I really appreciate it. I'm really glad that somebody likes my humor, even though a lot of people don't understand. Cheers, by the way. So if there is get window attribute, there should be something like set window attribute, I presume. Let me see if I can find such thing. It should be somewhere in the headers, right? GLFW set window attribute. Okay, so you can't set it. So attribute, context related attributes. Okay. So maybe we can search for the context, right? So context reference, GLW not initialized, context version major, OpenGL profile. I think that's one of the things we want to set, but we need to find a function where we can set that. Okay, I can Google it up. OpenGLW set core profile. How do you do that? Stack Overflow, show me all of your secrets. It's a window hint, of course. To get the window attribute, it is called get window attribute, but to set window attribute, it's GLFW window hint, of course. Very intuitive. Thank you so much. I really appreciate that. GLFW developers, very cool. Yeah, obviously, who would have, like, why didn't I guess that? Of course, it's GL window hint. It's so symmetrical with GLFW get window attribute, of course. Anyway, though I kind of understand why it is like that, because like it does not necessarily set the window attribute, it like hints the window attribute, but whatever. Because you have to do that before creating the window, I think, right? So, yeah. And in here, I'll be able to set OpenGL profile and stuff like that. Okay. So OpenGL profile and glfw, OpenGL core, core profile. There we go. glfw window hint, glfw context, I suppose, context version measure, and I think I'm going to set it 3. I think it is supported. So at some point, if it's not supported, the entire initialization is going to fail anyway, so we can just like basically bisect that. Right. Maybe we even have support for the 4th one, but I don't really know anything about the 4th one, so I'm going to work with the 3rd one. Alright, so we already have some errors in here. And the errors are related to what? Oh yeah, there we go. This is precisely what I was talking about. Yeah, I switched to the core profile and now it immediately complains about not having any VAO object. VAO object. O in VAO stands for object. Yeah, well, it already complains about having no VAO, and this is what I was actually surprised at, right? So because you need to have that in like in a core profile, but in a legacy profile, I think it's just like created for you implicitly, so you don't have to do that. So this is precisely why I wanted to switch to the core profile. I wonder how far I can push the version. Is there something like 3.4? I'm not familiar with OpenGL. I'm not a graphics programmer, so I don't really know all of the like details. Maybe some of these versions don't make any sense, but I'm gonna just try to initialize 3.4. And it says could not create window, but doesn't explain why, which sucks, right? I wish I could see why exactly you could not initialize window. I think this is because I have to do something like glfw get error, and I think the latest, like my version of glfw doesn't have get error, even though like generally the latest one does have it, get error. So error handling, I think, yeah, you can set error callback, and that's about it, which is not, like, I don't really like that. For some reason, like, I don't like handling errors through a callback. It's just like kind of weird to me. I'd like to perform an operation and then just like call something to get me the description of the error that just happened. It's just like, it is kind of weird, not gonna lie. So, and maybe this is why I didn't handle this entire thing, so whatever. Okay, so anyway, 3.3 works, and now what we need to do, we just need to simply try to create the Vertex Array object. So let me go to docs.gl and find the function that does that. GL again, Vertex Arrays. I think this is how you do that, right? So you generate a Vertex Array. So let's take a look at it. We've got a sub from Jimbolimbo13. Thank you so much for Twitch Prime, your first subscription, by the way, and welcome to our epic OpenGL club. How about that? All right, so let me now create VAO. After we loaded all of the extensions and checked all of the supported extensions and stuff like that. So maybe it probably makes sense to do that somewhere here. So we reloaded the shaders. Yeah, let's actually put it in here, right? So gluint VAO, and what I want to do, I want to generate a single one, right? So it's going to be 1, and then I'm going to provide the pointer to this entire thing. Okay, so we generated a vertex, and then I need to do a gl bind vertex array, I think. Gl bind vertex array, so gl3. Yeah, that's basically it. And I'm just going to provide VAO. Okay, so let's try to recompile the entire thing, and now it works. Look at that. Right, we updated the version to the core profile, and we created VAO, and now everything works because it's using the VAO. Setting 3.3 had you running 4.2 before. Oh yeah, it is actually running 4.2. Okay, very well then. It's only a hint though, that's kind of strange. Maybe... Oh yeah, maybe that's the only core profile that I have in here, which is kind of strange. All right, so maybe we can check something. Compatibility. It doesn't really force this thing, huh? All right, I'll get back to that a little bit later. So again, I'm not an OpenGL developer, so I might not actually necessarily understand what I'm doing. So yeah, sorry. Okay. So let's commit whatever we have in here, and let me see. So let's say switch to core profile. Let's switch to core profile, and I'm going to push that right into the repo. Also, if I remember correctly, you could set the shaders to core in here. I think you could do that. So this is the fragment, and this is going to be the vertex shader. Right, and let me see if that actually changes anything. Okay, this does not compile, and let me see. Is not supported, so you only have to have, all right, so 3.3. Okay, I wonder if I can just set that thing in here, 3.3, just without the core, and the fragment 3.3 as well. I don't remember when you have to put core in here, so yeah, now it works. Okay, so that's fine. All right, that is it. So the next thing I want to do, I want to essentially create the vertex buffer. We need to decide how exactly are we going to, you know, handle the vertices, right? So we're sending some vertices in the vertex buffer to the GPU, but how exactly do we interpret them, right? What exactly are we going to do with them? That's a very, very good question. I think we can, well, it depends on the drawing mode, right? So you send them, you can interpret them as triangles, you can interpret them as strips, maybe as quads, but people say you're not supposed to use quads, but yeah, usually as triangles. And what's going to be the attributes, the vertex attributes of these triangles that we're sending to the GPU? I think it's going to be position, right? So maybe two-dimensional one, right? Because right now I'm not going to be doing any 3D graphics, right? So only 2D. So the position, the color, and UV coordinates in case we're going to do some textures and stuff like that. So yeah, the usual classic stuff. I think that's pretty much it. So because of that, I would like to maybe define some sort of a vertex structure. Let me try to do that. So vertex structure, I'm not sure where I'm going to define that, but let's define it somewhere here. So type dev struct, and this is the vertex. Vertex. Cool. So here we have position X and Y. Right? Is that how we do that? I forgot how you specify the attributes, right? So if you have I think you have to do something like let's just specify X and Y. I think that's going to be fine, but we might as well actually have something like this, vec to F, and this is going to be the position, right? So this is the position, and then we're going to have UV, and then we're going to have something like this, and this is going to be the color. Right, there we go. And I think you basically, when you define the attribute, you specify the offsets within the structure, and then you just can use that. I think this is how it's done. So who took my name? Thank you so much for Twitch fans acquisition. Thank you, and welcome to our epic OpenGL club. Okay. So I don't really have these things defined, and do I even use any math library? So I think I'm gonna bring the you know, linear algebra library that I have on the GitHub somewhere. It's a pretty dumb linear algebra library, but it's a good start, I think. So I'm gonna be using this thing. If anyone is interested, I'm gonna actually copy paste it in here. Okay, so I'm going to go in the description. Thank you so much, Hector HSC, for 100 bits. Thank you, thank you, thank you. I really appreciate the support. So, linear algebra library in C. So this is the thing that we're going to be using. And let me take a look. So the interesting thing about this linear algebra library is that it's procedurally generated. Right, so let me show you. So since we're programming in C, we don't have any templates, right? And because of that, in C, you have to copy-paste a lot. And here we have a lot of copy-paste for different types of vectors, for different operations on vectors and stuff like that. But what's cool about these operations is that they have some sort of a system, right? So they have a prefix that describes the input and output types and the operation and stuff like that. And all of that, I didn't write that manually. I have like the generator that generates this stuff for you. Right, so, and in the repo itself, right, if you take a look at the repo, let me actually take a look. The generator is somewhere there. Yeah, it's called lag, right? So the thing itself is called LA, linear algebra, and lag is a linear algebra generator, right? And it's just like another C program that generates this header. So that's what it is. I'm not sure how good of an idea this is, but it's fine if you want to just get quickly the, you know, some vectors and stuff like that. And that's precisely what I want to have in here, right? I just want to have the, you know, support for vec2f, vec2f4f, and yeah. So, but I didn't think they're called like that. They're literally called v2f, so there's no vec in here, right? It's something like this. And if I remember correctly, LA is a STB style header library, so that means I'll have to do something like LA implementation. Right, yeah, there we go. I have to define LA implementation because the header itself is header and the C file simultaneously, right? So, and to make it act like a C file, I have to do LA implementation. LA implementation. Okay. So let's go. I'm gonna try to compile this entire thing, and it seems to be compiling. It seems to be compiling. Yeah, there we go. Okay, so here's the vertex, and I actually want to move it closer to the state of the program because this is the place from which I'm gonna be factoring things out. And I want to have some sort of a vertex buffer, right? Some sort of vertex buffer with limited maybe capacity, right? So we're not gonna go with you know, stretchy buffer or anything like that. So we got some bits. Who took my name? Thank you so much for 245 bits. Thank you, thank you, thank you. I really appreciate the support. Okay. So let's define something like vertex buff capacity. Right, and it's going to be, let's say we're going to have 1024 vertices in here. And let's define vertex buff, and that's going to be the capacity. That's going to be the capacity, and we also want to probably keep track how many vertices we have in that buffer on the CPU. So let's actually define vertex buff size, and initially it's going to be 0, right? Something like this. And so we probably want to be able to just easily push stuff into that vertex buffer. So let's define something like vertex buff push. And I'm gonna just provide these things as arguments: vec2f position, vec2f uv, vec4f caller, right? And that's essentially what we're doing in here. So sz position equal position, then uv is uv, and then color. And then I take this thing and I just increment it by 1. But there is one important thing that we need to check, that we don't overflow the size. Is the size less than the vertex capacity, right? If it's less, only then we want to do this entire thing. So that way we'll be able to, like, in loop maybe populate this buffer and then sync that buffer with you know, the GPU vertex buffer, and then display this entire thing. So Okay, so let's go and create the vertex buffer, I suppose. Let's create the vertex buffer. If I remember correctly, we'll have to use GL vertex buffer. I think it's gen. Gen vertex. I think it's a buffer object. Yeah, again buffers. Naming is always good. Okay, so let me see. And so this is where we create the VAO, and here we're gonna create VBO, right? So who knows what's the difference between VAO and VBO? the main question that people ask every time, right? What's the difference between these two? So if I understand correctly, VBO basically is the storage that stores the data, right? You store the data, and VAO basically describes the layout of that data, basically. And what's interesting is that the layout of that data can describe the layout across several buffers, right? You can, for instance, I think, store like maybe some part of the vertex attribute in one buffer and some parts of the vertex attribute in another one. You can store everything at once. It's just like it's a really complicated thing. I think I already explained that. Anyways, so let me do something like this. So it's gonna be pointer VBO, and we do this thing, and then we have to bind that buffer, right? GL bind buffer. Just a second. Deep Singularity, thank you so much for 10 months of tier 1 subscription. Thank you, and welcome back to our OpenGL club. All right, so, and let me see. So we also have to specify the target. I think we're talking about GL array buffer right now. That's what we're talking about. That's what we've been waiting for. That's what it's all about. And the buffer that I'm going to be using is going to be VBO. All right, so that should be it, I think. So the next thing we need to do, we need to start... excuse me. We need to start basically defining the vertex attributes, I think. Yeah, so basically that's what it is. Oh, we also need to define the data. Yeah, there we go. So GL buffer data. Okay. So let's define this entire thing. GL buffer data. GL array. So essentially, like buffer, I'm creating some space on GPU, I think. I think that's what I'm doing, right? So, and buffer is basically that. Then the size is going to be the size of vertex buffer in bytes. Then I'm going to provide the vertex buffer. And the usage, I think I'm going to be using that for dynamic draw, I think. Right, I think dynamic draw, because I'm going to be constantly modifying this entire thing. So dynamic, the data stored will be modified repeatedly and used many times. Yeah, it's a dynamic draw, definitely. So let's put it like this. All right. So after that, I need to basically define the parameters. GL vertex. I don't remember. I think it's a GL enable vertex attribute array. Yeah, that's the thing we need. So enable or disable generic vertex attributes array. Okay, so it would be nice to have some sort of enumeration that describes all of the vertex attributes we have, right? So if we take a look at the vertex, here are all of the vertex attributes we have, right? So we have a position, we have UV, and we have a color. Usually what I like to do, I like to have enumeration that just describes all of them, so I can use the values of those enumerations as the, IDs of these vertex attributes. So vertex attrib, right? So here's the vertex attrib. And here we're going to have VA position, VA position, VA UV, and VA color, right? So here are the things that they're going to start with 0, and maybe we're going to have something like count VAs to know how many all these things we have, so I can just iterate in a loop through all of the vertex attributes and stuff like that. So yes, go away, freaking this. Then, if I'm going to be enabling different vertex attributes, I can straight up just use the values of those enumerations. Be Freddy, thank you so much for tier 1 subscription, your first subscription, by the way, and welcome to our epic OpenGL club. Thank you, thank you, thank you. All right, so let me go back into the GL bind buffer, and this is basically what I'm going to be calling in here. All right, so I'm gonna do VA, what is it called, VA position, right, then VA UV, and then VA color, right, so we're gonna be enabling those things, and this is enumeration. Thank you, compiler, very cool. All right, okay. So, and after we enable the particular attribute, I think we have to do something like GL point, yeah, GL, I keep forgetting what it is. Vertex attrib. Yeah, vertex attrib pointer. Okay, cool. So you need to enable certain thing, and then you have to describe this entire thing. So this is actually rather interesting. Right. So let's actually describe the position. So this is going to be VA position, and what is the size? The size is the number of components per generic vertex attribute, 1, 2, 3, or 4. Right, we know that position is actually 2, so I'm going to put 2 in here. So the type is the, you know, type of the component, right? In our case, all of them are floats. I can just use GL float in that case. Float. It's not going to be normalized as far as I can tell, so it's going to be false. And here is an interesting thing. Stride specifies the byte offset between consecutive generic vertex attributes. It's essentially the offset within the structure, if we're going to be defining the layout like that, right? So yeah, we have like basically a sequence of vertices, and this stride is going to be basically offset in here, I think. Understood to be tightly packed in an array. Okay, so let's define it like this. This is going to be offset off, and I don't remember how to use offset off. Let me see. Offset off. The first thing is the type, and the second one is the member. So this is going to be vertex, and we're going to put a position in here. And the pointer specifies the offset of the first component. Wait a second. I think I fucked up. I think stride is essentially the size of the structure. Right, so the stride is the size of the structure. The byte offset between consecutive yeah, okay, so that means it has to be size of. So this is the size of vertex, right, so the size of this entire thing. And then is going to be offset of vertex position. Okay, so that is very, very poggers. Okay, so everything seems to be compiling. And the next attribute that we want to define is UV. It's literally similar, but we're going to just use a different offset. And for the color, we're going to be using the vector 4 and the offset color, and that should work. So there we go. So we defined VAO, we created VBO associated with that VAO, and we defined its size, and we just said that the size of that VBO has to be the size of that array, and we defined the layout, right? We defined the vertex attributes. So now the OpenGL context should understand what the hell we're talking about, hopefully. I'm not 100% sure. All right, so let me see if this entire thing compiles. It does not compile. Offset of what you didn't like. Passing arguments, oh yeah, I see. Without the cost. int conversion. So stride accepts expected const int. Oh, I see. So it wants like void star in here, if I understand correctly. That's what it wants. It's gonna be void star. Void star. Okay. So seems to be working. Let me try to run the entire program and see if the logging generates any errors. I didn't see any errors so far. I reload the shaders, everything seems to be okay, so we can just like go ahead and do that. Nice. Very, very cool. Hopefully I did everything correctly. So now, what's gonna be the next thing we wanna do? I think what we wanna do, for now at least, is just like pass the attributes through, right? So we're gonna open the vertex shader, and in here we're gonna just accept the vertex attributes that we have and just pass them along to the fragment shader. Though I don't quite remember how to do accept the vertex attributes, so let's actually Google it up. GLSL vertex attributes, vertex specification. Vertex specification. How do you do that? Annoying. Very, very annoying. I specifically asked for GLSL. Right. Specifically asked for GLSL, but I didn't get any GLSL as usual. So vertex shader, maybe this is where we can get that. So I don't remember the form. Yeah, there we go. This is what I was talking about. Yeah, layout, location, and stuff like that. Perfect. That's exactly what I wanted. Right, so it's going to be 0. So this is sort of like input, and this is going to be vector 2. So let's call it ver position because it's a vertex, right? Then we have that, and this one is going to be UV, and then we're going to have something like this, and this is going to be the color, right? But the color has to be vector 4, right? So let me try to compile that, and the shader seems to be compiling, right? Might as well, I don't have to restart the entire thing. I can always just forget semicolon, recompile, and it will complain about the lack of the semicolon, and then I can just fix that and recompile, because I can reload the shaders, right? I can auto reload them. Alright, I think we're getting somewhere. So as you can see here, we're essentially generating the quad. Instead of generating, as I already said, I want to try to just pass it through. So, and maybe that's precisely what we want to try to do, right? So I'm going to do if 0, else. So if I remember correctly, you can use preprocessor in GLSL, so that should be possible. And then I can do GL position equal to var pos. So right now that will break everything, as you can see. Well, it didn't really break anything at all. That's really strange. Oh, because I have to do it like that. There we go. So as you can see, it broke everything. Because it's a vector 2, right? So I have to do vector 4, then 0, and then 1. And if I reload that, it has to be black screen. So this is pretty much expected because we don't have a single vertex attributes in the buffer. Like we don't have anything in there. Right. So we first have to maybe populate the vertex buffer, at least a tiny bit. So the question is how we're going to be interpreting them. So maybe we can interpret them as strips. It just like depends on the draw mode. Right, it depends on the draw mode. So just a second. Let me actually bring my graphical tablet. So because I want to draw a little bit. I want to draw what I'm about to explain. Just a second, I need to plug it in because my USB hub is far away. Fortunately, professional streamer should have prepared like beforehand, but I didn't. Okay, so my paint. Okay, so I'm gonna just like provide 4 points for the quad, and we're gonna interpret that as a strip. All right, so we're gonna have something like this, right? So 1, 2, 3, 4. Motherfucker on the floor. Sorry. So this is gonna be -1, 1, -1, 1. Right. So the first one is gonna be -1, -1, -1, 1. 1, -1, 1, 1. Okay, I see how it goes. So this is gonna be that. Vertex buff push. So that's the thing we want to have. V2F is going to be -1, -1. UV coordinates, I'm not sure. I think I'm going to just keep them very simple. V2F is going to be 0, 0, 0, 0. And the color, I don't know, we can use the red one, or maybe we can just like have nothing. I wonder if we can just like do something like that and see. I don't remember if I can. But yeah. I'm gonna just put like this. Let's use the black one. Then X is supposed to be 1, but Y is gonna be -1. I'm not sure about UV. Let's actually not focus about UV. Alright, because it's just too much for my brain to process. So I just want to fill up the regular coordinates. So we have something like this, right? And if we try to compile and run it, it's still black, and this is because we didn't send any information to the GPU. Right, just because we put some data into the vertex buffer, it doesn't mean that it is in the vertex buffer on the GPU. We have to sync this entire thing. Right, so let me actually try to have some function, vertex buff sync, right? And what it's going to do is just going to use something like GL buffer subdata to send the current content of the buffer to the GPU. So yeah, subdata. This is the function that I usually use for that because it's rather convenient. So right now I'm writing a code that assumes like only one VAO and only one VBO, but that's fine. I'm gonna change that in later when it's not true anymore. So here's the GL vertex, actually, array buffer. The offset is gonna be 0, right? I'm not like sending like part of it, like I'm starting from the beginning. And the size is essentially size of vertex. Multiplied by the amount of elements, vertex buffer size. There we go. And I'm sending the data from vertex buffer, right? So this is basically synchronization, right? Synchronization between the data on CPU and the GPU. So, and we're gonna periodically call this function to sync the data. Right now we're gonna only call it once. Vertex buff sync. Right, there we go. So we just put some vertices in there and we synchronize the buffers. Alright, and that didn't change anything. Yay! I'm super happy. This is the classic, am I right? This is the classic. Oh. I wonder what exactly is wrong in there. Yikes. So, first parameter vertex attribute pointer is wrong. Oh yeah, I see. Thank you so much. Okay, I was about to actually bust out the render doc, but you saved me. Thank you so much. All right, so now it works. Yay! That's epic. That is absolutely epic. What's cool now is that I can try to modify this data and accept, like, put something like 0.5 instead of 1, right? And this entire thing will become smaller, essentially, right? So as you can see, it is way smaller now. And maybe I can make it even smaller, 0.25, right? 0.25. So that means I can actually try to put 2 of them, right? So if I put the second one, but I have set one of them a little bit, right? It's going to be something like plus, I don't know, 0.25f. Right, so we're gonna have the second one, and we actually don't have the second one because GLDrawArray draws specifically for vertices. So if we draw 8 of them, you can see 2 of these things, as you can see. So yeah, we finally transitioned from a single quad to 2 quads. In fact, we can draw as many quads as we want, as many as our buffer fits in there, right? Because we have a limited buffer. So this is something that we'll have to deal with. So I was thinking, how can I have a renderer that has a limited buffer, but it needs to draw, you know, the amount of elements that is bigger than its buffer, right? And I think the way we can do that is that basically the renderer can accept, like, push things into it, and once it reaches its limit, it sort of flashes everything it has and performs a draw call, so that it can continue, you know, accepting more and more things. Something like that, I think. And maybe this is exactly what we're going to implement today. We'll see, we'll see. And by the way, the amount of vertices that we have in here is literally equal to vertex buff size. We can just, like, use that in here, and that's basically it. So, and now if I add more of these things, right? So, and if I take this stuff and in fact add half of it, right? So this one is going to be third one. So now we have 3 of those things. We have 3 of those things. Very, very epic. Very, very epic. Cool. So I'm also thinking, so it's considered to be a strip, but if we put them, like, far apart, yeah, it's actually kind of a lame strip, if you know what I mean. It's kind of a lame strip. And we're also using the position as the UV coordinates, so yeah, now we need to add support for the UV coordinates. That's one of the things we'll have to do. So how long am I streaming? I'm streaming already for 1 hour. I would like to make a small break and make a cup of tea. And after the cup of tea, I'm going to try to, you know, handle UV coordinates and also the colors. So, yeah. All right. So what I want you to do, I think we're going to have a problem if I try to spread the quads a little bit more far apart. Though it's not particularly convenient to do it in here, so I would like to just, like, replace some of these things with a smaller stuff, 125. But then in here I can't really do that because, yeah, because then I'll touch these parts. But okay, this is something I can probably do. 0.25, 0.125, and just, like, do it like that. And here query replace that like that as well. So because of this, I can try to do it like that. Plus 0.5f. Actually, it has to be 25. So I'm also thinking that maybe I could extract this kind of stuff to a separate variable. So it's going to be 0.25f. So this is a, and then I'm gonna just query replace some of this stuff. Query replace 0.125f a. There we go. So, and then we're gonna have something like offset. I'm gonna call it b, which is like 25f. So in here, I'm gonna query replace 25f with b, and this one is rather interesting because it's 5. B to B. Boom. So now I can control these 2 parameters and just, like, a little bit easier for me to experiment with this thing. There we go. So they're, like, a little bit more far apart. And I have a feeling that if I make them even more far apart, right, if I increase the offset to, like, 30, right, they're gonna, yeah, they look kind of weird, right? So they're not really quads because of the, you know, because the triangle strips. Right, what we need to do here, we need to draw them maybe as triangles, right? So if I try to draw them as triangles, yet again, they're not going to look good. They're not going to look good because for a single quad, you actually need 2 triangles. So if I want to be able to draw these like separate quads using triangles, every time I render a single quad, I want to split it into two triangles. Right, you see what's going on here? So like the strips does not fit in here, right, because you can't draw them separately. Just triangles, you cannot just switch to just triangles because you need to prepare the data. So this is something that I want to quickly probably fix. I might as well introduce a function, something like vertex buff push quad, right, and it will accept literally like 4 points in here, right, it will accept 4 points. And it will split them into two triangles for you automatically. So this is something that we can do in here. All right, so I just provide these 4 things, and it will just split everything automatically. This is basically what I want to have in here. Right. Shigiman, thank you so much for tier 1 subscription, for 13 months of tier 1 subscription. Thank you, thank you, thank you, and welcome to our epic OpenGL club. How about that? Cheers, by the way. Thank you, thank you, thank you, thank you. All right, so let's go. Vertex buff push. So, and in here, we're gonna just accept 4 points. V to F, A, and I'm gonna just copy that B, C, this is not really what I wanted, D. Cool. So, and in here, we're just going to perform 6 vertex buff pushes. Right. So this is what we're going to perform in here. So for now, UV, I'm probably not going to care about UV and color, though we can kind of derive UV from here, or maybe we can accept UV from here. So it's kind of a... it's kind of complicated, but it's fine, I guess. I guess it's fine. Vertex buff push. So we need to do, if these things are following. I'm sorry that I hit my mic stand. A. Right, so this is basically A, B, C, D. So I need to provide essentially A, B, C and B, C, D. Okay, that makes sense. That makes sense. Okay, so the setup with the tablet is not convenient. I'll have to do something about that at some point. Push A, vec to F0. Might as well actually put something like UV and color, and then define UV like that, right? So, and the color like that. Right. A, B, C, B, C, D. All right. A, B, C, B, C, D. So now I can just push the quad like that. And because of that, I think I'm gonna do it like this. So A plus B 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 plus B. And for the fourth one, instead of B, we're gonna have 2B. This was dumb. What I wanted is... I guess something like this, right? Though it would be easier to do that manually. Okay. So now we have separate things in here, and it's almost correct. It is almost correct, and I wonder why it is really not. Because I forgot to... Yeah, I see. I forgot to put 2 in here. There we go. Oh, there we go. So now we have like separate quads in here, which is rather convenient. I think it is in fact rather convenient. It would be nice to also now provide the UV coordinates, right? So we need to provide the UV coordinates and then use those UV coordinates for the actual shading, because right now it's kind of strange, isn't it? I think. Well, it's kind of not, because we're using the position, so they're kind of, yeah, they go through one to another. Yeah, I see what's going on in here. So it's kind of meh. Though if we increase the size, so here is the size. Though maybe it could be something like 2. Right, 200, and then we pull them apart a little bit. They're gonna look like shit, but I just want to be able to see what the hell is going on. Right, that's what I want to be able to do. So, and in a fragment shader, if I go into the fragment shader, can I just squash it down a little bit? I don't remember how to do that. So it's a sine, cosine. Oh boy. So maybe if I multiply this thing by like 5. Okay, so that's precisely how I want to be able to do that. So if I make it, so I just want to be able to see like very specific. Yeah, I just want to see that they sort of share the same big texture. So I want you to make it more visible that they share it. But I want them to have the same texture, right? I want them to have the same texture, and for that we'll need to pass UV coordinates and stuff like that. It's interesting how UV coordinates apparently affected by the mouse, though it is not visible, right? So I'm moving the mouse around and it's not really visible at all. So, okay. So let me actually put it like that. So it's a little bit more calm now. So this is something that we'll have to fix. So, and passing UV coordinates in there is actually really not convenient. Right, so if we want to have like a push quad, right? So what is a push quad? So we provide the position. So these are just the positions. We can even just prefix them with position, position, position. There we go. And then here we can just do position and position. That's cool. And then if we want to have like UV coordinates, right? Pass the UV coordinates somehow, we'll have to, well, yeah, I thought that maybe we're gonna pass them like this, but that is only needed if you want to have like very fucked up UV coordinates on a quad. Usually if you push in a quad, you expect, I think, A to be 0, 0, and D to be 1, 1, right? So we can make this function automatically generate the UV coordinates for you, so you don't have to pass them. I think we can do that. I do think so. All right, so that means I'm gonna actually go back in terms of like this kind of stuff. Right, so, and in terms of UV, this one is gonna be 0, 0, right? So this is 0, 0. B is 1, 0, 1, 0. This one is 0, 1. And this stuff kind of repeats itself, right? At least in here. And in here we're gonna do just something like that. Okay. So. Alright, so nothing broke, and now we accept UV coordinates, which is nice. So let me put this stuff in here, right, and I'm gonna go into the fragment shader. Though I need to go into the vertex shader, because now I'll need to pass not only the position, so this is how I pass the position, but I also need to pass the UV coordinates, right? So the UV coordinates that we've got. We don't need this code anymore, I think, right? Because that's going to be the official way of, you know, processing the vertices. And let's provide the out for the UV coordinates. So this is basically going to be out. And I'm going to put it like this. So ver UV, we're not going to actually transform them. Everything seems to be compiling, right? So the shaders are successfully reloaded. And I'm going to go into the fragment thing. And here, instead of the coordinate UVs, right? So basically we use the screen as the like UV coordinates and stuff like that. We're going to be just like using the UV. Not really sure. So might as well. Oh, it's a length. This is a really weird way of doing that. Like, what the fuck is this? Some sort of a radius? T time. Oh, it's some sort of a. I see. That is really weird, but I guess it's fine. Oh, this could be very interesting. This could be very interesting if we replace coord UV with just UV. Huh. Alright, so, and this is going to be in vec4 UV. Okay, and it broke, of course. It broke. What's the error? So what do you want from me? What do you want? No matching function. Length UV. This is because, yeah, I'm gonna get this actually vector 2. Alright, so this one is interesting. Oh, and it's kind of affected by the mouse. Alright, so as you can see, they are using the same texture. And it's kind of affected by the mouse as well. Which is kind of cool. I think. If we had more of these things, I think that would be actually pretty epic. And I think we can have more of those things. I think we can. Huh. So what we can do, we can define some sort of a grid and just put those things on the grid. So let me see. Define grid rows. It's going to be 10. Then columns. We're going to have 10 by 10. And essentially we're going to have cell width, which is 1 divided by the grid columns, right? So this is the amount of columns. And then the height, right? So this is going to be the height. This is basically rows. And what I want to do in here is just essentially iterate through this entire thing. I'm not sure why auto-completion, indentation freaking out. Okay, so it's not freaking out anymore. Y equal 0, so it's basically rows. Grid rows plus y, and then we're gonna have something like int x grid columns plus x. And this is where we want to put this entire stuff, right? Oh boy. So essentially, it's actually not 1, it is 2. Because the normalized device coordinates are -1, 1, -1, 1. So that means width and height are 2. So let's actually put 2 in here. And we're starting all of that from -1, -1. Okay, so -1. -1, and then we add the cell width, right? We add the cell width, though we don't really add it, right? So we just use that, then we use this thing again, but this time we add cell width, and then here we don't add cell width, but we add cell height. And then on the last one, we just add both of them. Cell width, cell height. So there we go. and we're just essentially pushing a bunch of quads in there. We don't need this thing, and then we're just synchronizing those quads. So yeah, we're gonna have a grid of all of these things, and let's see if it's gonna work now. It didn't work. I'm really happy. I wonder why. So I wonder why. I think I know why. Because I never actually used x and y anywhere. So it has to be something like plus x plus y. Right, yeah, we literally have to actually add them. Plus x plus y. This one has to be plus x. Though I'm not sure about plus y, I think, yeah. Man, this is really inconvenient. Plus x plus y. I just want to be able to see shit. It's hard to see anything in here. Right, if we align all of that stuff like that, oh, there we go. So now it is more or less visible what the fuck is going on. Alright, so it kind of worked, but at the same time it kind of didn't. And you know why? It doesn't make any sense. Right, it doesn't make any sense because... right, I'm using the vertex buff size, so that's cool. So we're supposed to have a lot of them, but they're so spread apart, I'm not really sure why. This is because it has to be also multiplied by this thing. So cell width, and this has to be cell height. There we go. Cool. Now we have that. So that's pretty cool, I think. It's a little bit trippy, to be fair, but yeah. It's pretty poggers. Okay. So, though unfortunately I can't really change the amount of the cells at runtime. Right, I cannot change the amount of the cells at runtime because it is baked on the CPU, right? So in the CPU I'll have to like change these values. So on a fragment the only thing I can probably change is like just multiply this thing by 10 or something, right? And oh, this is actually cool. For a second I thought that maybe it broke or something, but no, it didn't break. It's pretty cool. Okay, so we have some sort of a renderer now, all right, that we can use like to draw these things and whatnot. It would be also nice to be able to have like, I don't know, triangles or not, but maybe not, maybe it doesn't matter. So yeah, we have this thing, which is cool. Which is rather cool. So, and we can go back to the original sort of demo by just pushing a single quad in there. So we can just push quad, and that quad is essentially going to be... Though, here's an interesting thing. If I'm pushing a quad, why do I have to push 4 points? Isn't to push a quad... Don't we have to have only 2 points to push a quad? Why can't I just define something like... you know, -1, and then v2f like 1, 1, and it just like generates all of that for me automatically. Why can't I do that? I think I should be able to do that. See what I mean? So it will simplify my life dramatically, right? I don't have to generate the UV coordinates that are going to be generated for me. I don't have to generate the rest of the stuff. Apocryphos, thank you so much for tier 1 subscription. Thank you. I really appreciate that. Okay. So let's actually modify this function to accept 2 points instead, right? So let me see. So this is going to be P1 and P2, right? So P1 and P2. And here we can essentially just generate the rest of the stuff, right? So we're going to have A, which is P1. then we're gonna have B, V to F. So in terms of X, it's gonna be P2, but in terms of Y, I presume it's gonna be 1, right? Because this is 1, then by X we move in there. Okay, so in C is essentially going to be the other way around, right? And D is fully P2, right? So this is what we can have in here. So just provide 2 points, and yep, just that. Okay, go. So is it gonna work? It kind of worked, which is cool, but I'm gonna go back for our shader. All right, so everything seems to be okay. So this is basically the original thing, but now our renderer is capable of drawing several of such things, right? Which is kind of cool. And that's exactly what I was going for. I can't find any usage for the color right now, to be fair. But maybe we should pass the color. The color, I think it's quite important. So let's actually customize this thing like so. So this is going to be the color, and the color is going to be passed automatically for you. All right. So it wants it to be here. Can I put something like this in here? Is that a thing? Probably not, but I could try to do the for F, and it will work. Okay, cool. So yeah, we can try to see how to work with colors. Right, in a fragment shader, well, we'll have to pass that color there, right? So we'll have to do something like out vec2 color, right, and then we'll have to do something like color and vertex color. The tokenization of this mode is actually kind of painful, right? So, and in the fragment shader, we'll have to accept the color. Vec2, actually 4. It also has to be 4. Color. For 1. Out, color, color. We can do something like this, you see? Then I can do end if. Now, if I try to run this entire thing, it says that it's black, right? It says that it's black, but if we set some color on the CPU, right? So we should be able to now set colors from the CPU. It's going to be something like, let's set blue, right? To distinguish from the actual compilation errors and whatnot. Right, so this is going to be something like that, and okay. That is already very interesting. Well, it's not blue, it's green. Okay, I see. I think I'm already getting tired, so this is fine. But yeah, so we can pass colors in there, though it's I'm not sure how we're gonna use all of that, but now we have an ability to just draw a bunch of rectangles. We can draw a bunch of rectangles with different colors. In fact, we can try to draw like a checkerboard. Right, so let's try to do that just to test things around. So grid row, I'll need to bring the code that I wrote back, and unfortunately I thought that I'm not going to need it, but I need it again, so I'll have to re-implement it. Okay, so it's going to be y0 grid rows plus y, right, plus yx, cool. And in here, vec2 vertex buffer push quad, and in here it should be a little bit easier. Vec to f, because we only have 2 points in here, right? So this is the first point, and the first point is going to be -1 plus x multiplied by cell width minus 1f plus y cell height. So this is the first point, right? And in here, in fact, we just want to do something like this. And then we can define a color. And how we're going to define the color? Well, we can do something like if x plus y mod 2 equals 0, that means we're going to use, I don't know, red color. Right, otherwise we're going to use the black color. So let me see if that will compile now. It's not going to compile because I need to define those things. So cell width is essentially 2 divided by grid columns, and height is the rows. Cool, so now we have that. Who cares? They're equal. Who cares? I get the shit done. Nobody cares. Okay. People care about useless shit. I swear to God. Okay. So we can do this kind of stuff, which is nice. So, as I already said, I wanted to kind of extract this entire thing into a separate, maybe renderer. Right, because we're having quite a lot of things in a state right now, right? So this is basically the entire state, and it would be nice to actually like have a structure, right? A structure that stores this entire thing. Yep, that would be kind of nice. But I'm not sure how to abstract it out though. I'm not sure if I even care. Maybe it's not that much. Because like I want to introduce a structure, a renderer, right? A renderer. And here's the question. Things like time and pose, they should be probably not part of the renderer. Only like shader programs and vertex buffers should be part of the renderer. Only those things. So in the pose and time, where do they belong? That's the real question. Where do they belong? They belong in some sort of maybe separate controller or separate state or something like that. They could actually stay maybe global, I think. I think they could stay global. For now, because they're very small. This is a small amount of state to be actually abstracted out to anything, so I didn't think it makes sense. But the uniforms, the shader programs, and the vertex buffers, they already like a pretty solid abstraction, and we can just call it a renderer. And that renderer will be capable of rendering rectangles for now, at least, right? But then we can start extending this kind of stuff, right? And yeah. So that's what we can do. Right, but before I do that, I want to actually go ahead and just like commit whatever I have. Right, but without this stuff. I kind of want to remove it again, but then I feel like, do I want to remove it? I'm not sure, because it's kind of useful, right? Let's actually abstract it out, because this is already like the second time that I needed to implement this thing. So maybe it makes sense to just abstract it out in case I need it again. Right, in case I need it again. So let me do that. So vertex buff push, right? So we can already push a single quad. How about being able to push a grid, right? Vertex buffer push grid of quads. And in here we can accept maybe the grid size, right? So it's going to be integer grid size, and that's basically it. Yeah, so for now it's going to be that. If we need more customization here, we'll probably add that customization, but not for now. Right, So, and then I will need to define something like cell width, which is going to be 2 divided by grid size, and cell height 2 divided by grid size, and this entire thing is going to be something like this. In terms of colors, I don't really know how we're going to be doing all of that. Yeah, so this function, actually, let's call it push checker board. Right, and if I'll need this code again, I'll be able to easily modify that. So that's the idea. Right, if I need it again, I'll be able to easily modify that. Vertex buff push checkerboard, and the size is going to be 10 in here, and that's basically the thing we're pushing in here. So this one has to be like this. Can I abstract it? Select it? Okay, so at any point I can just say, how about 100? Oh, it's too big. It actually overflows the entire thing. What about 20? I think 20. Oh, really? It's that small? Bath capacity. Okay. What about like 8,000? Is it gonna be enough? Should be enough for everyone. Yeah, there we go. So the encoding is probably shit. But again, I think the way we're gonna do that is when you're pushing, right? When you're pushing more and more things, we're gonna like periodically flush the thing with the render draw, with the draw call. Yeah, I'm gonna periodically flush it with the draw call. Anyway, so what I want you to do is just like bring everything back. So Vertex Buffer push quad, and in here it's v2f -1 -1 v2f 1 1. MatewSF777, thank you so much for 37 months of Twitch Prime subscription. Thank you, and welcome back to our epic OpenGL club. How about that? All right, so, and here we'll have to provide the color, but the color doesn't really matter, right? So v4f. So, and I can go back to my fragment shader, right? If 1 0 and boom. Okay, so we're ready to commit the crime. We're ready to commit the crime. So that's a lot of things in here, but they were well worth it. Boom. Add support for vertex attributes. Right, so now we can have like vertex attributes. Now we can draw several quads and stuff like that. If we'll need to draw something else, we already have kind of like machinery that, you know, that does that. So it's just a matter of extending that machinery, if you know what I mean. Okay, so let me see if I can use the compiler to sort of factor out the renderer. I wonder if I can do that. How much time do I have? I think I have enough time to try to do that. There we go. So what's going to be the renderer? I think I'm going to define it like this. So this is going to be the renderer. Here I'm going to store GLU int. I think this is GLU int. Yeah, it's GLU int. GLU int VAO and also VBO. Right, so this renderer has a single VAO and single VBO. Then it is going to have the program and the uniforms, right? The corresponding uniforms of that specific program, right? And the vertex buffer. Walrus Wallace, thank you so much for 13 months of tier 1 subscription. Thank you. And welcome back to our OpenGL club. All right. So there we go. So we're gonna just define it like that, and I'm gonna try to simply remove these things from the main program and see in which places this entire thing will fail, and we're gonna just modify all of that, and hopefully we'll end up with like a proper renderer, right? So I'm not sure that the current time and whether the time is paused or not is part of the renderer, because this thing don't define the visual part. They're more like a control variables. But these things could be like, you know, part of the single renderer. And for now, I also think I'm gonna create a global renderer. Right, so we're gonna have a global renderer and also zero initialized, but I think the global variables are zero initialized anyway, so but I'm gonna do that just in case. Also, let's all like make all of them static. Right, I'll make all of them static. Okay, so let us see in which places this entire shit is gonna fuck up. In a lot of places, I really like that. Okay, so you cannot do that because this is not C++. Next one, of course. Vertex buff push. Okay, so I think instead of like this function, what we have to do renderer, maybe vertex push, right? So essentially you just like add a new vertex. And let's also accept the pointer to the renderer. Maybe I'm gonna call it just R. And in here, we just check this thing and update this stuff. Alright, so it's pretty cool. So now this is a method of the renderer, even though we're using C where there is no methods, but we logically think about this thing as a method. Alright, the next compilation error. The next one is in here, which is fair enough. Renderer push quad. Renderer R. Okay. This one is going to be something like renderer push. It's really strange why I call it vertex push, but this one is push quad. Maybe it should be called push vertex and push quad, because that makes a little bit more sense. Am I right, bike shaders? Alright, so this is gonna be something like this. Cool. Next one. Not really next one, because here we also have to do it like that. Alright, so we're just passing it through. Vertex push quad. So this one has to be a renderer push quad, and I have to provide the renderer. Renderer R. Renderer push checkerboard. Cool. Okay, so this is synchronization. Now, renderer sync, which is very interesting, right? So maybe instead of renderer sync, we could have something like renderer draw, which basically draws its own state. But let's actually finish refactoring, and then we can probably, you know, factor that out. So for now, the current goal right now is just like to pull all of these global variables into a single structure, right? And just make the entire thing compile. That's the current goal. Then we can, you know, prettify that a little bit. Okay, next one, main program. Okay, reload shaders. Okay, this is cool. Right, so we're reloading shaders, but that means this thing has to be essentially method of the renderer as well. Right, it has to be method of the renderer as well. So let's do something like a renderer, reload shaders, renderer R, and main program is R. And it, as far as now, it's also program failed. Okay, so but it's not really main program, it's just program. Then whether it's failed, then this thing. I might as well just go through the compilation errors now. Okay, so uniforms. Uniforms is rather interesting. R uniform. Then we get the location, and then we just specify it in there for the program. And then we say that this thing did not fail. Right, so when we reload the shaders, we automatically assume that the program failed, and then we do the things, and it's not failed only if we successfully did all of these things, right? So program not failed, then we set the colors and stuff like that. Okay. Okay, cool. So reloading the shaders. Renderer, reload shaders, and I have to provide the pointer to the global renderer. Might as well actually call this thing something like global renderer, just to indicate that it's global renderer. Right. So, right. So when you're reloading, you're actually reloading the shaders of the global renderer. That's what you're doing. Cool. Okay, this is interesting. This is interesting. So all of that stuff has to be part of the initialization of the renderer, right? So we want to have something like maybe a renderer init, and we just take the global renderer and we initializing it. And all of that is just initializing of the global renderer. So let's put it like this in here. Renderer R. Right, render init, and let's move all of that stuff in there. That is really interesting indentation, but okay. So here we don't have to do that, and let's actually go to the compilation errors. Right, so it has to be like this. Surprisingly, it didn't complain about that one, but okay. All right. Okay, so this one is a renderer push quad. So and then I have to provide the global renderer, and now renderer sync. Did I call it sync? Yeah, I called it sync. Okay. Global renderer program not failed. We're trying to render the program. Okay. Oh, this is very interesting. I think I just like used a little bit of Emacs magic and it fucked something over in here. It fucked something over really bad in here. Like, what the fuck? Excuse me. Alright, so let me actually remove that shit. What the fuck? Okay. So, I don't know. It's probably like some multiple curses shit. Okay. So, global renderer. Global renderer. Anything else? Global renderer. Cool. Okay, so we factored out the entire state of the renderer into a separate structure. Right. Look at that. So, yeah, all of this stuff were global variables. They are not global variables anymore, right? And a bunch of things that work with those global variables are now sort of methods of this entire thing. You see, this is exactly the reason why you shouldn't be scared of global variables, because there's this easy to just pull out into a separate structure, and now it's a self-contained thing that is not particularly global. We have a single global instance of this thing, but it's super easy to allocate it, for instance, on a heap and have a pointer to that thing in a scope of main without this thing being global. You see what I mean? It's just like different levels of visibility, right? So sometimes I have a cursor in some random place and type garbage everywhere. Yeah. So it is like that sometimes. And maybe you do want to allocate this thing in a dynamic memory, because like maybe this buffer will get very big, so it's like easier to put it in a heap or something like that. But yeah, so now we can even take this renderer, right? We can even take this renderer and probably pull it out into I don't know, into a separate like module, in a separate unit, right? So now we have a renderer. And we have the rest of the program that uses that renderer. You see, the modularity the people masturbate to all the time. I don't know. So let's actually do a commit and yesu. Factor out the renderer structure. Right, I'm gonna push that right into the repo. Alright, so I'm already streaming for almost 2 hours, and I think I already achieved my goal, right? So I added support for Vertex Buffers, and I factored out the renderer. So this Opengl template is a little bit more useful for me in the future, right? So as I already said, I use this template usually when I need to quickly prototype the Opengl application, right? I just like copy paste this thing, and here I have already working Opengl application. I don't have to initialize anything, I don't have to write the shader reloader or anything like that. And the only thing that it lacked is an ability to work with Vertex Buffers and Vertex Array objects and stuff like that. So, and I just like put this thing in here, and yeah, so that's basically everything that I wanted to do today. I guess that's it for today. Thanks everyone who's watching me right now. I hope it was interesting. I really appreciate you watching me, and thank you so much for all of the subscriptions, for all of the donations, all of the bits. I really appreciate that as well. And yeah, I see you next time. Maybe we should rate somebody. So let's take a look at who's streaming right now on the Science and Game Development section of Twitch. Is anyone doing any like graphics OpenGL stuff? So yeah. Was it interesting today? I think it was kind of interesting. I refreshed my knowledge of OpenGL because I haven't programmed OpenGL for quite some time. So it was very, very cool. So... I want to mute myself. Okay. Leo Slabs. What is he doing? I heard he's doing like some epic physics simulation. World's fastest fractal generator. Okay, so that sounds cool. So let's raid him. Leos Labs. Hope I pronounce his nickname correctly. Alright. So get ready for the raid, boys and girls. Get ready for the raid. And I see you all next time. Love you.